Welcome to PlayOwnAI. In today's episode, we're building a complete AI engineering team using CrewAI, a powerful multi-agent software development system designed for real-world workflows. You'll see how multiple specialized agents work together, including an engineering lead, a backend engineer, a front-end engineer, and a QA test engineer, all collaborating automatically. If you're interested in agentic AI, real-world automation, and advanced system
Build your
design,
AI engineering team with CrewAI, featuring multi-agent systems for advanced collaboration, powered by CrewAI.
you're in the right place. If you find this helpful, don't forget to like, subscribe, and support the channel. Let's open terminal or command prompt. CD to the CrewAI directory. CrewAI create Crew Engineering Team. Enter the number of your choice or Q to quit. I choose 1. Again, enter the number of your choice or Q to quit. I choose 6. Then enter skip for the next prompts until you reach the end. Let's open our engineering team on CrewAI. CD Engineering Team. Environment variables. First, let's set up our API keys. Create a file called .env in your project root. .env file. API_key_ here. serper_API_key. If you're using OpenAI or Anthropic, add those two. OpenAI_API_key. Anthropic_API_key. Save the file. These keys are now securely stored and ready to use. Open src/engineeringteam/config/agents.yaml. Define our engineering team agent. Now let's look at how we build a complete AI engineering team using CrewAI. First, we define the engineering lead. This agent takes high-level requirements and transforms them into a clear technical design. It defines the module structure, class name, and all function and method signatures. Everything in a single, self-contained Python module. Next, we have the Backend Engineer. This agent follows the design exactly and implements the full Python module. The goal is clean, efficient, production-ready code that can be tested or extended with a user interface. Then comes the Front-End Engineer. This agent specializes in Gradio and builds a simple UI to demonstrate the backend. The interface lives alongside the backend module, making it easy to test and showcase functionality. Finally, we add the Test Engineer. This agent writes proper unit tests for the backend module, ensuring reliability and correctness. All tests are created in the same directory so the entire project stays self-contained. Each role is powered by a specialized LLM, allowing every agent to focus on what it does best. Together, these agents form a fully autonomous AI engineering pipeline. From design, to implementation, to UI, to testing. Open src/engineeringteam/config/task.yaml. Now let's walk through how our multi-agent task pipeline works in CrewAI. We start with the design task. This task takes high-level requirements and produces a detailed technical design. The engineering lead outlines all classes and functions in a single Python module and outputs the design as a markdown file. Next comes the code task. Here, the backend engineer implements the design exactly as specified. The output is raw Python code only, ready to be saved and executed without any formatting. After that, we move to the front-end task. The front-end engineer creates a simple Gradio UI that demonstrates the backend functionality. This UI is intentionally minimal, designed as a quick prototype, and lives in the same directory as the backend module. Finally, we run the test task. The test engineer writes proper unit tests for the backend module, ensuring correctness and reliability. These tests are saved alongside the backend code so the entire project remains self-contained. Each task builds on the previous one using shared context, creating a fully automated AI engineering workflow. From design to implementation to UI to testing. Open src/engineeringteam/config/crew.py. Now let's bring everything together by looking at the engineering team crew. This class defines a complete AI-powered engineering team using CrewAI, where each agent plays a real-world role in the software development lifecycle. First, we define the engineering lead. This agent is responsible for architecture and system design. It converts high-level requirements into a clear, structured design that the rest of the team can follow. Next is the Backend Engineer. This agent takes the approved design and turns it into clean, executable Python code. For safety, we disable direct code execution, ensuring controlled and predictable outputs. Then we have the Frontend Engineer. This agent focuses on building a lightweight Gradio interface that demonstrates how the backend works. It's designed to be simple, functional, and easy to extend. After that comes the Test Engineer. This agent writes unit tests to validate the backend logic and ensure the system behaves correctly. Again, code execution is disabled for safety and reproducibility. Now let's talk about tasks. The design task runs first, producing a detailed system design. The code task follows, implementing that design exactly as specified. Next, the front-end task creates a working UI on top of the back-end. Finally, the test task verifies everything with automated tests. All of these tasks run sequentially, forming a complete end-to-end AI engineering pipeline. With just this one crew class, we've automated design, development, UI creation, and testing, powered entirely by collaborating AI agents. Open src/engineeringteam/main.py. At the top, we import our standard libraries and the engineering team crew. We also suppress unnecessary warnings to keep the output clean and readable. Next, we make sure an output directory exists. This is where all generated files, design documents, code, UI, and tests will be automatically saved. Then we define our project requirements. In this case, we're building a trading simulation account management system. The system supports account creation, deposits, withdrawals, share trading, portfolio valuation, profit and loss tracking, and transaction history. We also enforce real-world constraints. Users can't withdraw more than their balance, can't buy shares they can't afford, and can't sell shares they don't own. We then define two key parameters: the module name, which will be accounts.py, and the class name, which will be account. Inside the run function, we package everything into a single input dictionary and pass it directly to our CrewAI workflow. With one command, the engineering lead designs the system. The back-end engineer writes the core logic. The front-end engineer builds a demo UI. And the test engineer validates everything. Finally, when we run this file, the entire AI engineering pipeline executes automatically, turning plain text requirements into a complete, testable application. This is AI-driven software development, end-to-end. Now let's set up the environment and run the project step by step. First, we install the required CrewAI integrations. We add support for Google Generative AI and Anthropic models. so our agents can work with different LLM providers. Next, we install Lite LLM, which acts as a unified interface for managing multiple language models across providers. For convenience, we can also install everything in a single command. CrewAI with Google Gen AI, Anthropic, and Lite LLM together. Once the dependencies are ready, we run the project using the CrewAI CLI. This launches the entire multi-agent workflow. Design, backend development, front-end UI, and automated testing. After the run completes, we move into the output directory. This folder contains everything generated by our AI engineering team. Now we install Gradio, which powers the lightweight front-end interface. Finally, we launch the application using uvrunapp.py. This starts a simple web UI that lets us interact with the back-end system we just generated, without writing any additional code. And just like that, we've gone from plain text requirements to a fully working application, built by an AI-powered engineering team. Support line: get assist. Stuck anywhere, or feeling overwhelmed? No worries. Just follow the link in the description for more tutorials and smart automation tips. Visit my YouTube channel at PlayOwnAi. Still need help? Feel free to drop a comment below. I personally reply and I'm happy to assist. Thanks for watching. If you found even a bit of value, please subscribe and hit the bell so you don't miss my next AI automation guide. Your feedback helps me create the most useful content possible. So, what's on your mind? Tell me what you're struggling with in comments. I might just build a full tutorial on it for you. We release new videos every week. Let's build smarter together with PlayOwnAi Playground. Our mission is simple and ambitious: to help millions of people adapt to the AI revolution with clarity and confidence.